Welcome. Today we will be talking about the chain rule, which is the most important derivative formulas. So the chain rule used to find the derivative of composition of functions. So let's say that y is the composition of f and g. So y of x would be equal to f of g of x. Then the derivative of y would be derivative of f evaluated at g of x multiplied by g prime of x. So when we have the composition of f and g, which is basically f of g of x, then f is called the outside of the composition, g of x is called the inside of the composition. So notice that in the derivative, we have the derivative of the outside evaluated at the inside multiplied by the derivative of the inside. So once again, if y is f of g of x, then the derivative of y is f prime of g of x times g prime of x. Now I'm going to rewrite this formula a bit differently. So if I take u to be g of x, then notice that, so if u is g of x, then notice that y would be f of u. Then here we are trying to find the derivative of y. So if you are looking at the composition function here, here y is a function of x. So we are trying to find dy dx. So derivative of y with respect to x here can be written as f prime of u multiplied by g prime of x. So remember, g of x is u. So this is f prime of u multiplied by g prime of x. But f prime of u is the same as the derivative of y with respect to u. So the derivative of y with respect to u is f prime of u. And then g prime of x is the derivative of u with respect to x. So basically, we can rewrite this formula in this way, where we have dy dx is equal to dy du multiplied by du dx. So the derivative of y with respect to x is equal to the derivative of y with respect to u multiplied by the derivative of u with respect to x. So here we took u to be the inside, and then y became f of u, and we're going to do that in some of the examples. So here's my first example. Let's say that y is the function x cubed plus 1 to the power 5. To find the derivative here, we first notice that y is the composition of the function f and g, where f of x is x to the 5 and g of x is x cubed plus 1. So if you look at the function x cubed plus 1 to the 5, you almost wish that x cubed plus 1 was just an x, because then you have a simple function x to the 5. So here the outside is x to the 5, and then inside is x cubed plus 1. So the derivative of the outside is 5x to the 4. The derivative of the inside here would be 3x squared. And so the derivative of y would be the derivative of f evaluated at g of x multiplied by g prime of x. Now g of x is x cubed plus 1. So in the formula for f prime of x here, we replace x by x cubed plus 1. So you get f prime of x cubed plus 1 multiplied by g prime of x, which is 3x squared. So then we have basically f prime of x cubed plus 1 is the same as 5 times x cubed plus 1 to the 4 multiplied by 3x squared. And so this is equal to 15 x squared times x cubed plus 1 to the 4. Now I'm going to redo this question again. The y is x cubed plus 1 to the 5, and we want to find the derivative of y with respect to x. So here, if you look at this function, the outside function would be x to the 5, the inside is x cubed plus 1. So we take u to be x cubed plus 1, then y would be u to the 5. Now, the derivative of y with respect to x is the derivative of y with respect to u multiplied by the derivative of u with respect to x. And the derivative of y with respect to u would be 5u to the 4. And the derivative of u with respect to x would be 3x squared. And then we substitute back in u, so u is x cubed plus 1, so that's what we put back in. And then we get 15x squared, x cubed plus 1 to the 4. So either way, we got the same answer. Okay, so now let's look at this function. Y is equal to the root of 7 minus 2x. We can rewrite this function as 7 minus 2x to the half. So now if you look at this function, we almost wish that 7 minus 2x was just an x, because then you would have x to the half, and then we can find the derivative of that by using the power rule. So here the outside function is x to the half, the inside function is 7 minus 2x. So this function here is the composition of f and g. So f prime of x is half x to the power negative f, and then g prime of x is negative 2. Now we know that y prime by the chain rule is equal to f prime evaluated at g of x multiplied by g prime of x, which is equal to f prime evaluated at 7 minus 2x, because that's g of x, and g prime of x is negative 2. Now what is f prime of 7 minus 2x? Well, this is f prime of x, so f prime of 7 minus 2x would be half 7 minus 2x to the negative half. And after we cancel 2, we get negative 7 minus 2x to the negative half, which we can rewrite as negative 1 over, so this quantity here can be written as 1 over 7 minus 2x to the positive half, which is the same as 1 over root of 7 minus 2x. So that's the derivative of this given function. So the here is the general power rule. If I have a function g of x to the power n, then the derivative of that is equal to n g of x to the n minus 1 multiplied by g prime of x. So this is by the chain rule, because so here x to the n is this is the composition of the function x to the n and the function g of x. So you take the derivative of x to the n, which is n x to the n minus 1, but you evaluate that at g of x, and then you multiply by the derivative of g. So let's apply this general power formula. So let's say I want to find the derivative of the function 1 over 1 minus x to the 4 to the 7. The first thing I'm going to do is rewrite that as the function 1 minus x to the 4 to the power negative 7. So now I have some function to the power negative 7. So by this general power rule, the derivative here is equal to is equal to, so basically you would wish that 1 minus x to the 4 is just x, in which case we just have x to the negative 7. So the derivative will be negative 7 x to the negative 7 minus 1, which is negative 8. Now, this is not just x, so we multiply by the derivative of that. So this would be the derivative of 1 minus x to the 4. And that gives us negative 7 times 1 minus x to the 4 to the negative 8 multiplied by negative 4x cubed. And then we can multiply negative 4 and negative 7, which gives us 28x cubed 1 minus x to the 4 to the power negative 8. So once again, at this point, we apply the power rule here, which is basically a consequence of the chain rule. So n here is negative 7, g here is 1 minus x to the 4. So we get negative 7, 1 minus x to the 4 to the power negative 8 multiplied by 1 minus the derivative of 1 minus x to the 4. So once again here, like I said, when you look at this function, you almost wish 1 minus x to the 4 was just an x. So then you just have x to the negative 7, and the derivative of that is negative 7x to the negative 8. But then you replace x by this function 1 minus x to the 4, and then you multiply by the derivative of this function. One final step is that 1 minus x to the 4 to the negative 8 can be written as 1 over 1 minus x to the 4 to the positive 8. So let's say now we want to find the derivative of the cube root of 5 minus 12w. The first thing I'm going to do is rewrite the function as 5 minus 12w to the power 1/3. So cube root is the same as taking the power 1/3 here. And now we have something to the power 1/3, so we can apply the general power rule. So this would be, so basically again, 5 minus 12w is, if this were just w, then the derivative would be 1/3 w to the 1/3 minus 1. So 1/3 w to the 1/3 minus 1, and 1/3 minus 1 is negative 2/3. But this is not just w, so this is 5 minus 12w, so we multiply by the derivative of 5 minus 12w, and then what we get is 1/3 5 minus 12w to the negative 2/3 multiplied by negative 12. And 1/3 and negative 12 reduces to a negative 4. So we get negative 4 times 5 minus 12w to the negative 2/3. And finally, we get negative 4 divided by, so this could be written as 1 over 5 minus 12w to the negative 2/3. Positive 2/3 in the denominator, but that can be rewritten as the third root of 5 minus 12w to the 2. Again, when you take the cube root, it means you take this to the power 1/3. Okay, so that's the derivative in this case. So I'll stop the video here, and I will see you in the next one.